मैक्स निकालो। सर को कैसे दिखेगा? अरे यार पूछने का समय थोड़ी यार अब।
Satyam, can you? I can hear you. What happened? It's okay.
यस सर
Yes,
वैसे
sir. Yes, 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 sir.
Good morning, all of you. Sorry for the slight delay due to the technical lag. So I welcome you all onto the day 6 of this 3-week summer training program on geospatial technology. And as you all know, we are Northeast Center for Technology Application and Reach, NECTUP, headquartered at Shillong, currently at Survey of India campus, Bonibra State. We also have an office in Delhi. And this is a very brief intro about NECTUP. So this is the today's agenda. Today we'll be studying the basics of cartography and data interoperability. So we will be having a theory session on basics of map making, and then we have a theory session on basics of cartography, and then we will be moving forward for the practical sessions of those, followed by I will be taking the theory session on basics of data interoperability and practical sessions on data interoperability. So about today's speaker, he is Sri Rajendra Jaina, Chief Geomatics Officer, Northeast Center for Technology Application and Reach. He has more than 15 years of experience in working as a junior commissioned officer in Military Survey Directorate, and 12 plus years of experience on working in various positions as Scientist B, Technology Officer, Deputy Director and Chief Geomatics Officer at NECTUP, DST, IMOSNT, Government of India, with professional exposure on development and supervision of various high precision GIS and remote sensing application projects and products, including experience of general technical administration and management activities. And you can see both the speakers today in the picture. So this is about the second speaker, that is me, Satyam Tripathi. I am Junior Geomatics Officer at Northeast Center for Technology Application and Reach. I have more than 5 years of experience in applications of remote sensing and GIS in forestry, urban studies, agriculture using microwave, optical and other satellite data sets with remote sensing centers, state remote sensing centers, ISRO and Ministry of Agriculture. I also have experience in crop forecast, forest resource mapping and forest canopy density mapping, urban solar potential, rooftop mapping, and competent with software such as ADAS Imagine, ArcGIS, Snap, QGIS, Mapnik, Tilecache, WebGIS and NV. So many of them are open source softwares and many of them are licensed softwares. So now I hand over mic to today's first speaker, Sri Rajendra Jaina, Chief Geomatics Officer, NECTUP, to start the proceedings. Thank you all.
possible to see their face that how they are feeling, or can they interact? Some of these students. I would like to know what is their enthusiasm and what actually basically is it possible, people?
Yes, sir. We are doing that.
Yeah. of map making process, topographic mapping and surveying methods, changing role of cartography under GIS and information security. These are all brief. Basically, you can have your theory reading from the internet sources. It's a very small gist of exposure about the topics I have given. So hopefully you will be getting quite understandingly, and further you can start reading transport network diagrams, natural resources, economic activities. These are all different variety of maps. If you work on more, then you will come to know how to represent different kind of features, different kind of themes, different kind of subjects. So accordingly, the map will be evolved, I think. So basically, what GIS and remote sensing caters to provide the topographic maps, which shows the topography or landform by tradition, other features such as roads, railways, boundaries, etc. Then out of those topographic maps, we can have a customized maps like thematic maps, geologic maps, cadastral maps. They carry some amount of theme along with the map when we represent the features about the specific subject or specific theme. So map for computer and internet use, since the computer and internet has come up, I have already told that these have recently grown in a very advanced way of representing things, and the concept of GIS and remote sensing has evolved. And basically, GIS is the first launching pad, which is becoming the core of the digital mapping. I mean, when we are switching to digital technology, the GIS is the core. So you have to learn the GIS, basics of GIS. What are the components of GIS? How can you create a GIS? So that is very much important to have a digital technology of map making and cartography. So it has gone to the next slide, slide number 6.
Not yet, sir.
Not yet. It's cartography, I think.
We are on types of maps, sir.
No, I have already changed to next slide. I don't know why it is not changing. Or you can display. I have shared the PPT there
Yes,
from
sir.
there.
We
Is it
will
possible?
display from here then.
So then I'll tell next to next. Then you can proceed. Okay.
Okay, sir.
So I'm stop sharing.
Okay, sir. Sir,
I can't see any PPT.
sir, sir.
हेलो.
हेलो. हाँ सर, सुन पा रहे हैं सर?
हाँ मैं सुन पा रहा हूँ बट मैं पीपीटी नहीं देख पा रहा हूँ
हेलो.
मेरा वाला. हाँ धर्मेंद्र. Is it okay?
Yes, sir. Sir,
Shall I start?
share the presentation, sir.
Shall I start?
Yes,
Hello.
sir.
Can I continue?
Yes, sir.
Okay. So the types of map you have already got idea that what are the different kinds of maps you can use. Of course, with practicing a lot of GIS and remote sensing, and you can have more number of or more type of maps. You can generate your own, having a specific theme, providing some design elements in the map. But what's all the basic is the cartography and the use of maps under cartography. Maps assisted us in our intellectual growth and development and have been passed from generation to generation, helping us in the development of our society and culture. And people have produced and utilized maps as necessary tools to help them identify, understand, and navigate their way around. Basically, if you provide some information in a textual format or in a language, a communication language, then something it is time consuming for a reader or for a people who would like to know about the things. But if you are presenting the same in the form of map, then that will be very much very much understandable for him easily with less time. And that's how you have to design the map such a way that quickly how a person or map reader can easily see it and get some interpretation and have a analysis and their understanding and about the environment or about the understanding of the objects there in the map. So that is the use basically to have a quick and uh, convenient way of presenting things. Then, of course, while doing so, a lot of art and science is involved. So basically, that process of map making, presenting any things to the map reader in a convenient way is called cartography, and the study and practice of the components of the map or map making is also called a cartography. So that is a art as well as a science also. A lot of mathematical knowledge is required because it involves the positional coordinate, and as earlier told in the being day that every map has some location, and once you see the location or once you visualize the location, definitely it is a location in a coordinate system. If it is two-dimensional coordinate system, it will be x y. If it will be in three-dimensional coordinate system, then it will be x y z. And if it is time, then x y z and t. So this cartography is not an art of designing or presenting objects, but also it is a mathematics. So you have to learn little about mathematics also. Of course, not a higher standard mathematics, but basically the 10th level and 12th level mathematics is okay. So apart from designing and producing maps, cartography includes studying the history of maps, printing, publishing, distributing and collecting and conserving and curating in the map libraries. Because uh, as you know, the map has a time as a space. So and every objects or art features are changing day by day. So if you archive a map of older or historical time, then definitely it will be help for studying the change, and accordingly you have to plan your design or the objective of the map making or developmental issues. So definitely archiving the maps is one of main activity. Then of course this is a conventional hard copy map. Uh, how it can be archived in a different stores or different cupboards or different sections of their office. But when the electronic technology has advanced in 20th century, it has led to a new revolution in cartography. So the computer hardware devices such as computer screens, printers, scanners, and the processing of maps, like image processing. How do you visualize the map? You have all changed your visualization since 20 years back. The visualization was somehow different. Now you're in a younger age and in a modern age of photography, pictures. So visualization has changed. Spatial analysis also, you have a very uh, powerful analytic power now students have, and all this analysis carries some sort of in the background in database software. These have all extended the ability to provide maps which have numerous kind of features, different kind of features of Earth. And it has made possible the creation of maps with fine details, resolution, and remove the need of repetitive engraving drawing, which reduce the time to create and reproduce the very good qualitative and quantitative map. Since earlier, what people have made one maps, the one maps, one copy of maps that has been reproduced in many copies, millions of copies, and distributed like newspapers, hard copy newspaper are distributed. But nowadays, you can store it in a computer, in a memory, in an internet, World Wide Web. So these are all modern technology which helps us to change the scenario of the cartography and map making. The next is how the cartography is related in the topographic map making process. Basically, topographic mapping is a mapping of collection of topographical geographical features of Earth, both man-made and natural, along with relief, precise location coordinates to create or project a topographic database. What is topographic database? Topographic database is basically the list of features or the gamut of collection of Earth features which have uh, organized in a database way. That is topographic data. Though the conventional process is a little bit complex and laborious and time consuming, but IT and computer application technologies, basically GIS and RS, is now making it relatively simple and less time consuming. But all the basic principle of topographic mapping process or surveying or collecting objects in cartography has five basic elements. Basically, you have to work from whole to part. For example, you are going to map Guwahati, then definitely you will consider Assam as a whole state. Then start from Assam. You'll have some idea about Assam. Then where is the district the Guwahati is locating or Guwahati is falling? So you have to come from state to district, then district to maybe subdivision or tehsil or taluk, then it will come into the Guwahati city. So large area to small area, that is from working from whole to part. So you have to control or you have to get hold of the larger area first if you are willing to map a smaller area. So the whole to part is the basic principle. You have to start from whole to part only. Otherwise, if you are starting from Guwahati, then you will end up with some kind of error in when you reach to the district level or when you reach to the state level. So whole to part is one basic principle that you have to start while making a map or while surveying for a map. Then location of point by measurement from 2 points of reference. For example, map is a representation of two-dimensional, three-dimensional, or four-dimensional coordinates. Like every location is either two-dimensional XY or three-dimensional XYZ or four-dimensional. But every coordinate has some reference point. Something like in coordinate system, you have a origin 0, 0. From there only you measure the X or Y at a particular point of location. So fixing positions by relative position on location. So first you have to identify the 0. Where is 0, 0? The origin. Or where is some point of reference? For example, you are mapping total world, complete world, then definitely it will be a matter of identifying 0, 0. But if you are identifying or you are mapping a Guwahati city, then definitely it is not 0, 0 you have to identify basically, but you have to identify some nearest control point, nearest starting point, or nearest reference point. So always anything you are going to map for each location, there will be a reference point definitely. With that reference only, we will try to measure the distance in X, Y, and Z directions. Then consistency of work. Whatever you are work doing in the field or lab should be consistent. The methodology, the process, that should be a single, should not be biased on the results. So consistently work is very much important. Initially, you have to decide what is your methodology, what is your process. That process should not be changed in any point of time while surveying or mapping in a cartography. Then independent check. Of course, whatever you are doing in the process, collecting data, symbolizing, then presenting the data in the form of map, this all process should have a definite point of control. For example, point of check. If you do some work, then check whether I am doing correct or not. Because if you are not doing that, then you will, without checking, you will go to the end of the map making, or you will produce the result, then there will be an issue. There will be a problem of errors. There are a lot of sources of errors. Human errors are there. There are some process errors. There are some instrument errors. So that has to be checked independently in between. That is, independent check is must for surveying and cartography. Then accuracy required. Accuracy is, of course, one focus point you need to decide first initially, because the use of map depends on the accuracy. For example, if you are using a general purpose map, then your accuracy will be coarse. If you are using very precise, for example, I was in military survey, we are using very precise maps because our weapons are basically meant to hit a target. Basically, the modern weapons have some kind of coordinate system or mapping system to be fed so that the weapons can target a particular object. So in that case, the accuracy is very much required. So you have to very much sure about what is your accuracy of mapping or surveying. Initially, the first question would be like this. Accordingly, your scale of work, your resolution, all to be fixed. That is the must for any mapping and surveying activities. So these are all basic principles of surveying and mapping. You should focus on these before starting some work on mapping and or remote sensing GIS also. And what are the elements of cartography or mapping? Basically, map projection, because you are projecting some real world space to into a piece of paper, or into a very into a piece of paper, or in a screen, or in a bed printer, for example, you are projecting the map. So map projection is very much essential. It's a very separate topic. There are a lot of mathematics behind the map projection. So you have to read very carefully about the map projection, and how this map projection or projection system you will use for presenting a map. Then reference datum is also very much important, because our Earth is not a plain surface. Basically, it's an undulating surface. There are a lot of hills, lot of water features which are low-lying features. So the variation of heights, or Z, you can say the elevation, requires a reference datum. Every reference datum has its own pros and cons, so you have to decide the reference datum. Then scale is one factor. You know how you will represent in a piece of paper. Whether you are getting a small piece of paper, then what is the scale? If you are getting a small, medium, or big paper size, or big screen, then what would be your scale? It is basically a ratio. Then cartographic design principles are also one of the vital elements that human perceptions can give a better visualization of quick reading of these objects that you are presenting in a map. So the first is map projection. So basically, there are four character, or maybe parameter. You can say distance, direction, shape, and area. So since you are presenting the the part of the earth in a piece of paper, so every element or every object on the surface of the earth has some distance relation. So that distance relation should be preserved while projecting back to the paper in a piece of paper. Then it should have a direction. Basically, our direction is north. North is one direction, which is the reference direction for all people. Always we can refer north. So how the object is deviated from the north, or what is the angle? So it is a distance, linear measurement, then angular measurement, direction. You should know the direction. In which direction this any kind of object is placed in a map. So direction is one factor. Then shape. What is the size of the object? It's a point object, or it's an aerial object, or it's a big object we have to map. So that shape is also, and area, whether it's a 10 hectares of area or 15 hectares of area. So these all four parameters need to be preserved. Whatever they are in ground, that should also have some sort of a scale while projecting those features on a plain piece of paper. So projection is very important. And the reference datum is also, I'm telling, the Z, which is essential to map a four-dimensional map, or basically in topographic map, we generally represent the contours, the elevation as a contour. So it's basically the contours or the heights, the elevation is basically with reference to a constant surface, which can be used to describe the location of unknown points on Earth. The unknown points on Earth, the normal reference datum is sea level. On other planets such as the Moon or Mars, the datum is the average radius of the planet. So this picture, you can see the Earth's surface is the brown line. I mean the brown color line is the Earth's surface, quite undulating. It will get a sea or below the sea level, the Earth is there, and the high hillocks and high hills are also there in the Earth's surface. And the green line is the geode, and the black line is ellipsoid. So what is difference between geode and ellipsoid? Geode is something like a localized reference surface or reference datum, you can say. For example, India is the highest peak is Everest, and we have also the sea. So under the sea, there is a very deep surface, or the elevation in the sea is from the mean sea level is quite negative. The value of the sea surface is very low. Similarly, in India, the elevated on the surface or above the surface is Everest point. So the quite difference of variation of elevation is there in India. So when we use ellipsoid, for example, WGS 84 is called ellipsoid because it's a very generic reference surface or reference datum, which is being referred by the community, mapping community of the world. But when you are working with a precise map or accurate map, then this ellipsoid sometimes gives error. Your target failed. So definitely you will have another surface, another reference data you have to create, that is called geode. So it's a local surface. Like in India, we are using Everest datum. One scientist have developed this geode, where this geode can give a very good accuracy in Indian continent. You'll find in ArcGIS there are a lot of datums are there. Mr. Satyam and Mr. Dharmendra can show you that how this
Sir, you are not audible.
Hello, can you hear me now?
Yes, sir.
So I think what I have given in the previous slide, the first component of cartography, it was there. Am I audible there in that time?
Yes, sir.
So you got the idea about the map projection and reference data.
Student can answer them.
No, it's okay. Actually, I was audible in that time while
Yes, sir.
explaining this slide.
Yes, sir.
Or should I repeat?
No, no, sir. You were audible till then, sir. So you can start from this slide, sir.
Dharmendra, can you hear me?
Yes, sir.
Actually, I think I have some issue here also. There will be some network issue. That's why I'm getting problem. I'm switching to my laptop. Okay, just hold on for 1 minute. Then
Okay,
I'll
okay,
carry from here. Okay, I'm just
okay,
exiting from here. I'll join again. Okay.
okay, sir.
Yeah, can you hear me now?
Yes, sir.
Yeah. So the previous slide, what I have given the lecture now. I mean, the
We can start from this slide, sir.
okay. So you have got the idea about the previous slide.
Yes, sir.
Okay. So the next component is the map scale. Basically, it's a, representative factor or ratio of distance on the map to the actual distance on the ground. So scale is one of the vital element. You have to represent or present scale also below a map. Without that, your map is not usable. I mean, not usable as a measurement purpose or as a GIS purpose or as a any kind of purpose. You have to have a scale there in the map. So what is scale? Basically, it's a RF or representative fraction from ground to paper. So any scale which is expressed in terms of 1 is to 1 lakh, what is written here. This is 1 centimeter in uh, paper is equivalent to 1 lakh centimeter in ground. If you use in unit as a meter, then 1 meter in piece of paper would be 1 lakh meter in ground. So it's a ratio basically. So you can have a measurement analysis if you have a scale. So there are a lot of bar graphs or bar charts. Why this bar graphs or bar scales is given? Because, uh, for example, in terms of or in place of a soft copy or GIS or digital technology, there is no need of any measurement. You have your mouse, you have your tools in software that can be used for measurement from one point to another point. But in a hard copy map, if you want to measure, for example, in troops, like in the wartime, troops are basically using hard copy maps. So while using a hard copy maps for planning and designing a operation, you have to have a measurement of distance. So every soldier or every map reader in ground who is using the hard copy map should have a bar scale or a divider. So a divider, in a compass or in a geometry box, the divider is there. So use the divider in this bar scale can be measured the actual distance from point to point in the map. So a location from map, a location in a map from point to another point can be measured using a divider, and the same distance can be placed in the bar graph, so that you can have a representation of what is the exact ground distance you have to cover, or you have to have to cover that distance. So bar graphs are might also important equally for analyzing or reading a map, or having a measurement analysis. Then it can be in miles, or it can be in feet also, as per the convention uh, units adopting different countries. Like in India, we are in metric system, and in US on they are using mile system. US, Europe, and they are also using feet system. Now the last line is contour interval 50 meters. Of course, any kind of two-dimensional measurement like x and y is can be measured from the scale in a map. But how do you map the or idea about the height, elevation? So there is no such scale here for measuring a z. So therefore, contour interval have to be written in a textual line in the map, so that what happens, anything, when you will see a contour line in a map, then you will immediately go what is the contour interval. I mean, every contour has some value, z value, and the next contour would be either plus 50 or minus 50. That much every 50 meter you will have a contour line. So accordingly, you can have a judge about the elevation, that where you are, whether you are exactly on a contour line, for example 760 or 750 meter, then you can guess that you are standing at an elevation from mean sea level of 750 meter. If you are standing the next line, then you can say that you are standing on elevation of 800 meter. But if you are in between these two lines, then you have to interpolate yourself, and in that place also you can use your divider. What is the difference or distance between the two contour lines? And you can have a division of 50 meter difference. For example, the difference between two contour line is 100 meter, and the elevation is now 50 meter. Then you can find out at what distance you are standing from one contour, and accordingly the height is also varied approximately. That means you can say that you are standing on an approximate mean sea level elevation part. So that is the map reading, and how a hard copy map can give this measurement analysis using these scales. Then another is National Geodetic Vertical Datum of 1929. This line is important because what in the earlier slide, I have given that there should be some reference datum while you are measuring Z or elevation. So here in this map, the reference datum is National Geodetic Vertical Datum of 1929. That means this is a basically US country map screenshot I have taken. That's why it is here National Geodetic Vertical Datum of 2029. So with reference to this datum, the elevation whatever given in the map, the contour values are according to this reference datum only. You cannot use in reference to the WGS 84 here now, or you cannot use the average datum. So that's why these two lines are very much important while explaining the scale. And it is a component of a cartography map. Not only hard copy, but also it also equally important in digital technology also. Next, please. Now, the next is the components of a topographic map regarding to the basic symbolization, color, pattern by line, area, and point. Of course, we are presenting all the features of the earth on a piece of paper, right? On a piece of paper or screen or in some media. Then when you are representing some objects or few objects or all objects of the earth, there should be some conventional sign or symbol. So in GIS, basically, there are three types of features. It's a point feature, that some objects you are going to represent in a line feature as a line feature, and some objects or some features you are going to represent in a piece of paper as area features. For example, the administrative boundary is an area feature. Roads, canals, these are line features. And there are some monumental items like temple, church, or some point specific locational features in earth on earth surface that will be represented as a point feature. So that's how there are three kinds of basic line features that you also will be working with digital technology. Then these are important. Then come to the color. Of course, all the features, whatever point, line, area, that should have a given importance when you will define it in a different color. For example, temple, you can show it in a red color, but while in church, you cannot say it can be in red color. It can be a different symbol as well as different color also. And so far as the color is defined, there are three mode of system of color generally using the basic, the primary color CYMK, the cyan, yellow, magenta, and black, and RGB also, and white. So these are two methods of color. Why these primary colors are important? Because while printing, if you define red color or define some kind of color, then it is, you can analyze, it is of combination of 3 or 4 colors. 4 colors when expressed in cyan, yellow, magenta, and black. And if you have a printing of RGB, then it has some percentage of red, some percentage of green, some percentage of blue. So if you are fixing a percentage of color, for example, you are using a color in a map, then that color has to be defined in a particular fixed percentage of cyan, yellow, magenta, black, or red, blue, green. That's why this color, once you fix some percentage, then this color will be always preserved. And whenever you take this color to print in anywhere in world, then the color will, the standard of the color or the appearance of the color will be same. That's why we have to fix the fraction of the component of basic colors. So that's why the color is important in cartography. The next is the pattern. There are certain elements which can be expressed as a pattern. So you are getting a point feature, you are getting a line feature, you are getting an area feature, then you have a color, then you have a pattern. These all 4 parameters, 5 parameters you can say, or variables, we can say visual variables. In cartography, we call it as a visual variables. So these visual variables are vital for representing or symbolizing any object on the surface of the earth in a plain piece of paper or in a map, so that variety of impressions or interpretation can be generated for a map reader. and easily it can be used for his use, or quickly he can grasp the features about the map or objects. So these are important: symbolization, color and pattern by line, area and point. So definitely it should be legible, it should be contrast, visual contrast, that any person which can can easily be identified or differentiate different types of objects. It should have symbols, very good differentiable symbols, because human eye cannot always see or differentiate easily. So you have to have a very good parameters or very good variables to represent the features on the paper, so that the human eye can differentiate it and quickly analyze or study the map. Next. Then one more component is map legend. Map legend is basically, it's a key to map reader. If you are not give the map legend, then definitely it will be a blind map. I mean, if you give a map without a legend, then the map reader will suffer a lot. He cannot able to read or reference what is the features, how you are depicting. So basically, all the features in general given in a legend, but there are maps where there are some features are not there, but still you have to depict the template. You have to create a template, map legend, and you have to place it. Whether in any part, all the features or some features are not there, but still you have to place the legend. That is a standard legend procedure. And these legends will be very much useful for quickly or referring for quick reference of while reading the map or while using the map. And another element is the contextual elements. These are basically title, the heading of the map. Legend, of course, I have given the source of citation. I mean, from which source this map has been generated, whether it has been generated from the field survey, or it has been generated from the satellite data, or it has been generated from aerial photographs, or it has been generated from the crowdsourcing data. So that citation must be there, source. Then map data. Map data means what are the different kinds of data, the volume of the data you should mention here, or what is the compilation source. For example, it has been combined in a hybrid source, like in satellite data and from field survey in a combined way. So map data, you have to tell about the map data. Then scale information you should have, and should have a north arrow. So these are the basic contextual elements you should put in a map. Of course, disclaimers. I mean, for example, there are certain points or silent features or certain drawbacks or certain cautions you have to put as a disclaimers, because if someone is using map and having getting a wrong coordinates or wrong information, then then that will be issue. That will be, because you are going to publish a map, it will be a public document or it will be a document for a group of users. So therefore you have to very much sure about the technology, about the procedure, about all this accuracy standard of this map. And if anything found not confident that you are putting is not correct, then you can put a disclaimer. Disclaimer means this map has some kind of error, or the contour interval is approximately given, or the water body is surveyed here as from aerial photograph. So the accuracy will be accordingly, the water bodies can be read or can be studied. So these are the all element of topographic map. Next. Then basics of topographic map making process. For example, there are three basic components. One is surveying or collection of data. Either it can be from the field or remote sensing technology. Field, that means you have to use field equipments or field surveying equipments. And if you are using from remote sensing, then it can be a satellite data or it can be a drone picture or anything, remote sensing technology. Then while you are using or surveying a map, the picture here in the lowest one, which is a very illegible map, line map. This is basically a field map. Immediately while surveying, you will not consider about the cartography or symbolization or pattern. It will be a hand sketch, something like that. But while reading this, you are only the person can read this and can decipher the information there in the map. So it's a very draft line map, because while surveying, your focus is only for surveying, collection of information, not the symbol, color, size, and that you will take care of. But when it will take to the lab or a GIS lab you are taking off, or you are in a drawing office, then you will more analyze. So in the fair mapping, you have all the elements of cartography has to be integrated for this line map. So this line map may be redesigned in a standard scale or standard symbol, standard line, standard color. Everything has to be there so that any map reader, layman, can study this. So that is preparation of a one draft copy of map, which will be laid in as a publishing format or given in a for public, and or you can say for a mass printing, like one copy, a good copy can be represented or reproduce large number of maps. So this is the third step, publishing and printing. So while publishing and printing, thoroughly that one copy of map is to be checked whether any error is there, because people are using people is going to use the map once you publish the map. So you have to have a very good legend, very good components of elements of cartography, and very good color scheme, so that public can use it and appreciate your work, and they have a benefit with ease and convenience. That is the basic purpose of the map layout. So it is a creative activity, art or skill that you will learn while practicing different features, point features, area features, line features. And of course, I think you will be not bothered about the reproduction. Like the reproduction of maps is, it's basically a press work. For example, if you send a one copy or one digital copy to press, then they will produce it million number of maps or million number of circulation through World Wide Web. I mean www. They can publish in the website. It can be circulated to any number of users. Next. Then steps of map making process. The first is you have to have boundary or limit of map territory. But I say the first principle is whole to map. So you have to know about what is the area of extent or area of interest of your map. Once given a task of map making, then you have to first identify what is the area, whether it's a tehsil, whether it's a taluk, or whether it's a district, or whether it's a small town. So you have to fix a boundary. Then next is you have to have a control point, ground control points, where the ground control points will be distributed over your AY, well distributed, because these ground control points will be used as a reference control point. What I said, every point in the principle of surveying, in principle of map making, I have given 5 bullets there. The second bullet is the every location should be relatively placed. So these reference GCPs are the basic coordinates or basic locations where any other object in that area, in your area of interest, should be placed in reference to GCP. So GCP's identification of GCP is very much essential. You have to survey GCPs first very accurately, because if these are wrong, then accordingly all the objects with reference to this GCP will also go wrong. So total measurement will go wrong. So GCP is a very vital component of map making. Then next is the detail mapping. Detail mapping is basically related to GCPs. What I explained here, there are number of numerous earth features are there on the surface of the earth. It's a line map. It's a line features. It's a point feature. It's area features. These all details need to be mapped in certain form of symbols. So every object on the surface of the earth or the interested object, for example, suppose you are going to make a tourist map, then all tourist places should be detailed, placed in the your area of interest. That is also a important vital part. Then elements of cartography. What I explained, elements of cartography, this should all be considered. Projection, then reference datum, then come to the symbolization, then come to the legend, then come to the scale, come to the north arrow. These all should be there. Then only it will be a completion of the map making process. Then you have to have a layout. For example, you have a huge amount of data, and only you wanted to have few. Like for example, you are creating a map for a patient monitoring or patient in a locality. So any patient can see where are the hospitals. So you are creating a map, hospitals, along with the roads or communication systems. Just a minute, sir. Good morning, sir. सर मैं थोड़ा सा ये ट्रेनिंग ले रहा था इनका ऑनलाइन में, आधा घंटा में आ जाऊंगा सर. थैंक यू. So basically, it's a layout you have to create for a patient or monitoring. I mean patient information system. It should have roads, or you should have communications, how the patients can be traveled to hospitals, and other associated details. So you have to decide yourself whether you are going to prepare a hospital, theme of hospital and patient map. Then you will decide what are the features you have to put in a layout format, and you will present a map. Then publishing, how this map can be published in a different forums, like hard copy format or in digital format in webs. Next, so when I call to the boundary, then you have to decide first boundary. Then I come to ground control points. Next, please. So these are the ground control points. Basically, it possesses some x coordinate, y coordinate, and z coordinate also. So these are the controls of this area. The next is the feature, your road feature you will digitize. Then next, then you will digitize some point features, maybe hospitals, maybe lakes, ponds, something like that. The next, then you will have some aerial features. Maybe these are tanks, something like that. So these are the detailed features you have to place accordingly in that sequence. Yeah. Then you will have go to the element cartography, then layout, then rest. Yeah. Okay. Go ahead, please. Then I just quickly give idea about the some conventional surveying methods. Still, in our system, we are using the conventional surveying methods because these are the state of art, accurate methods. Yes, go next slide, please. Next slide, please. Yeah, this is the surveying. The fundamental principle again is the whole to the part. You have a bigger area, then you will come to this lower area, then you will come to the next lower area. I mean district, tehsil, taluk, subdivision, then city, like that. But in every area, it has to be checked from at least 3 points. At least 3 points means it should be divided into a triangular area, because any object should be validated only from two other checks. For example, 1 point can be checked from two other persons or two other points, then that will be fixed. So, for example, a triangular division of total area into triangles, then getting ground control points, then you will have a survey lines from where you will start measurements, then precise instruments also accordingly you have to devise what is the type of survey, and cover whole area by dividing triangles. That is the basic principle of topographic surveying. And you can see the next picture. For example, there are three points A, B, C. So A, B are two main control survey stations, GCPs. For example, A is one GCP, B is one GCP, and you are going to find out or locate the point C. So there are many ways, 5 ways to locate C. You have to locate from the distance from A to C, and you can also locate by making a measurement from B to C, or you can have a perpendicular distance from C to this line from A to B. If you can draw a line from A to, because A or B are known coordinates, okay, you can draw a line between from A to B. So you can have a perpendicular distance from C to line. That is also one way of locating C. Another is the angle. That for example, in the third picture, it is given that at what angle from the line of A, B, C is presented. For example, this is theta 1. Here it is written theta 1, I think. It is legible, I think, for you because you are looking at a big screen. And at a what distance? At what angle and what distance from B? So C can also be located in that way also. So there are 5 ways or several ways of locating C. So every every methods has some different kind of surveying equipments. Basically, there are numerous kind of survey equipments are there based on their type of locating a new feature from a known feature or from known locations. So just next piece, next piece. Yeah. So basically, there are two types of survey: plane surveying and geodetic surveying. Plane surveying is something like only restricted to x and y coordinates, and of course the z is there, but these are all based on the Cartesian coordinate system. I mean rectangular coordinate system. Okay. Now, when we will go to the geodating surveying, then there will be a element of latitude, longitude. So latitude, longitude is again, it's a real earth coordinate system where you have some kind of reference latitude line and some kind of reference longitude line. So east of Greenwich is a main 0-degree longitude line. Basically, it's an angle. Latitude, latitude and longitude is basically angles from certain point of the Earth. That is, its nucleus. I mean, it's the center point of the sphere is the 0, 0, 0. So from that point, what is the angle in which direction? Whether it's a north direction or it's a south direction, then accordingly we will have a latitude. Then accordingly, we have to have a direction from east of Greenwich from either left direction or right direction. Accordingly, the longitude have some angle. So that's why latitude, longitude is expressed in angles. So when you will mapping in a geodetic surveying activity, then you will use the latitude, longitude coordinates. In that case, if you start measuring Cartesian coordinate, then that will be wrong. Therefore, while preparing a map layout, you have to have a decision of what is the system you are going to build a map, whether it will be a geodetic surveying map or whether it's a Cartesian coordinate system. So that is very essential. Which type of surveying or which type of map you are going to produce or generate. Next. So there are very survey instruments are there, chain and compass survey, which still people are using in revenue department. They are making all cadastral maps where both distance and angle is required, and they made a recording in a tabular format. Then plane table is one way of one instrument which use the graphical plotting of details by resection and intersection method. That is also mathematics, resection and intersection, that you have to study in theory in some part. Okay, these are all basic fundamental. It is still applies to the remote sensing GIS and modern facet of the technology. Okay, so you just have a theory reading how these basic principles can be useful for even in digital mapping also. The next is theodolite. Theodolite is also one instrument which is used for angular measurements and also distance, but it measures very long distance. Theodolite basically used for the ground control points. Then level is used for linear survey, like you are going to lay a railway line or lay roads, then levels are used. Then tachometry is also a angular theodolite, special kind of theodolite provided indirect measurement for horizontal and vertical distance. I mean angle as well as vertical distance. Total session nowadays the modern equipment which has evolved as comprising of all these. Like it has some component of plane tabling, it has some component of theodolite, it has some component of label. So total station is a total surveying instrument or station which is still being used in many of the surveying companies for road survey, for area survey, for construction building site survey, like that. So they has all angle, distance, and coordinates. Next, these are picture of theodolite. You can see if you will attach the telescope, then it also observes, and it is basically used for the GCP survey. Next, next, then triangulation. Sorry, next. Triangulation survey for monumental GPs. Basically, theodolite is the old technology where we GCP survey, but now Survey of India has come up with basically the survey points, the GCP points which are being surveyed by theodolite is monumented. Whatever in India we have monumental GCPs, you can say these are all monumental GCPs, maybe 300, 200 years of age, that was surveyed by theodolite or by star observation, north observation. These are still preserved in India. They are done by Britishers only. So these ground control points are still exist, and they are monumented in such a way that they cannot be destroyed easily, or they cannot change unless until earthquake or something happens. So they choose the location in such a way that there will no such drastic changes of Earth's surface will happen, and they create the monumental point in such a way that with some solid concrete kind of thing, and they have some description, clear description, reference description of those points, so that if you study the description, we can reach these GCPs easily, and we can engrave the soil, the top soil, then we will get this kind of the GCPs, monumental GCPs. And these are very useful for controlling the mapping process of the whole country. So this is one GCPs which are monumental, still there, you will find in many places. Next. But now what Survey of India has done, Survey of India is the basic mapping agency of India. What they have done, since we have a very poor network of GCPs. For example, the India is totally a huge country, but the number of GCPs are very less. So if you are starting from a GCP, then you have to travel around 200 kilometer, 100 kilometer. Then you will have to have a measurement there. Then in reference to that, you will measure other points. So what they have done, they have densified these GCPs, and they have used the modern technology, the satellite technology. For example, there are a lot of satellites revolving around Earth, which are responsible basically for sending signals to the Earth. So based on the measurement, the light, measurement of light and measurement of distance from satellite to the Earth, and time, space and time, the precise coordinate of multiple satellites. What I say now, the triangular measurement, for example, any point can be measured, any 3 satellites. So that point precisely can be precisely fixed through 3 satellites observing simultaneously and providing 3 kind of distance from satellite to point. So using that technology, they have designed a course, continuous observation reference stations. So about 2,500 cores have been now planned, and they are being installed, so that we have enough ground control points which can be directly used for starting our control work, because every survey will be start from a reference point. If you are going to map accurately, then you have to have a control point. This definitely you have to have 3-4 control points in your area. So if you are traveling 200 kilometer, 300 kilometer for identifying a control point, then it will be an issue. It will be expenditure. It will be time consuming. That's why Survey of India has come up to densify these ground control points using the satellite technology, and you will not able to travel, will travel much more distance, like 200. Now you will be able to around 25 kilometer of radius. You will have to have a 3, 4 ground control points. Then from that ground control points, you can start measuring other details or other features. So that is the technology has come up with the GCPs. Next. Then this is also lower level GCPs. Why it is called auxiliary? Because once we have a good network of GCPs, then you have to have some auxiliary GCPs also. Generally, you have to create temporarily some GCP points within the network. So this tachometry survey is one responsible for auxiliary GCP creation. Next. Then plain table serving, that is the detail serving. Plain table basically a table which is labeled, then a site rule is there, a tape is there. Using those instruments, you can have a map in the field or surveying in the field. So that is plain table surveying. You can go to the literature. I think you will able to find out. But nowadays, the modern technology has come up. There are a lot of alternate methods are there. So plain tabling is also one of the method. People are still using. Survey of India is using, but still it can be avoided. Next. Then chain and compass. Still, the patuaris, I mean the revenue persons are using this for measure. Suppose you are going to buy a plot, then before that you have to bifurcate a bigger plot. Basically, since you are buying a small part of a bigger plot, so that bifurcation of plot will be given using the chain and compass only. So this chain and compass is still possessed by the revenue department, and they generally when you request that you are going to buy a plot, please give a map of that so that the registration process will be completed. Then they will come up with chain. They will mark the location or the boundaries of your new plot which you are going to buy. So still they are using. Next. Then labeling survey is people are still doing for laying a railway line, for laying a road, something like that, because it has to be covered with some kind of elevation and linear distance. Next. These are all total session. I think the components of total session, they are not basically the conventional way of doing leverage work, but now it has been easy now. Using a total session, you can map very easily. Still, it is being used by the construction people. The government people are also doing for laying a road, because whatever remote sensing technology is there, we have to have a validation or field check. So either not completing field work through total session, but you can have a sample field checking, so that whatever you have collected from remote sensing, that has been correct or not, that has to be certified. So for that, total session is using. Next. Then traversing is one way of kind of labeling. So this is all our basic conventional method. Next. Yeah, this is important slide. I think changing role of cartography under GIS and RS technology environment. So now the cartography has completely in digital in both creation and use. So how you are creating your data or creating or surveying your data, that has been changed. Basically, survey and digitization of feature extraction from aerial photographs you are doing, satellite images you are doing, and you are generating ortho photographs. Yeah, ortho photographs, actually you have to know what is the difference between a simple photograph and ortho photographs. I think Mr. Satyam can explain there in I will have some kind of interaction later on, then I will say what is the ortho photographs. Then resolution and scale to be decided also. It's all in digital mapping. It is possible very easily. Then the next step is creation of a digital topographical database, DTDB. That means it's a database, not the conventional database that we are speaking in general, like we are Postgre or Microsoft Access, something like that. There are a lot of database softwares are there. While you are creating a database, we'll have a information table converted through that database. But when it is a topographical database, the information is quite related to topography of Earth's features. So that is it called it DTDB. Then digital cartographic database. For example, this DTDB is simply having line, point, and area and some pattern. when you will see it, you will only see some lines, some points, some areas, but you will have no information, no more information when you see a screen. Of course, when you click it, it will be a list of attributes, but without clicking, how do you see? So there is a general cartographic enhancement of DTDB will be done. That is called DCDB, Digital Cartographic Database. Then updating of DTDB is possible using remote sensing technology, because all the DTDBs are generally have some vintage of date and time. But whenever you are reviewing it, it can be updated immediately using remote sensing technology. Then what you have learned in last 2 weeks, you have learned the image processing, digital image processing, visual interpretation, feature classification, then image enhancement. These are all basically to capture the features, to survey the features. These are all assistant or assessment tools that how you can easily capture the features. If you do a classification, then you can get some information on location as well as theme you can collect from the image satellite data. Then visual interpretation also, you have an idea that what is this, what is this, what is this, then you can accordingly survey. Image processing is image enhancement. You can do, if it is not clear, you can enhance the image, you can see features and survey. Then the idea, the core of the this mapping technology now it is GIS. So you have to must learn the GIS, creation of geographical information system, by linking not only the spatial location but also the non-spatial information for any kind of thematic map or customized map. So it is basically GIS is the core of the map making process or cartography or whatever. So you have to create a GIS, you have to learn a GIS, you have to practice to create a GIS. So I request everybody that you should at least, maybe simple, you create a GIS in your during this period, and our experts are there. They are all very good in hands-on activities. They can explain to you how the GIS can be created. Maybe it is a simple, but you will get to know the basics of GIS so that you can add on future with a advanced knowledge. Then GIS can be used as standalone, published in web mode for various customized queries, and create different thematic maps on any interoperable formats. Yeah, your next lecture is interoperable formats, which Satyam will going to, because there is a big forum or community in world in GIS. They are working all in GIS and remote sensing. They have developed their own applications. So they have developed their formats. Sometimes the format from one application is not compatible to the other application. So in that case, we have to have a knowledge about the formats. So Mr. Satyam will take over this. This is very important. You have to must learn the, because you are working in any kind of departments in your state or in your district. There will be a revenue department. They are using one format of data. There will be a planning department. They are using one kind of format of data. So at the end of that, if you are a professional, GIS professional, you should have a knowledge that how these different formats can be converted to a operable format to your applications. For example, you are using ISRI software, ArcGIS, then you have to think of what ISRI ArcGIS understand. So that is the main vital step of learning interoperability of applications, both GIS application as well as remote sensing applications. Next. Yeah, basic the cartography is that you have to cover huge amount of data, or you collect huge amount of data, and this collection is placed in a server. Okay, but yet in a modern technology, in a digital technology, or in a advanced cartography, you can have different scales of map. You can have very large scale map, you can have a very small scale map, or you can have a very medium scale, depending on your area. For you are going to survey Khanapada area, then you have to have a detail mapping. You have a huge amount of detail. Suppose, because you are going to project them in a piece of paper or screen. and you have to analyze that, or to make you understand, to make them make the map understand to others. So accordingly you have to decide what is the scale of your work, or what is your output, desired output. So these are all very important steps. You have to collect data, then prepare data, and then data generalization for mapping different applications, then prepare cartographic data. You have to have a very good symbols, lines, points, patterns, colors. Then cartographic finishing is also required. There are a lot of errors while collecting the data, because some lines, some roads are overshooting, undershooting, they are not correct as per the distance what is in ground. So that has to be checked. So cartographic finishing is required before publishing a map or publishing a multi-scale map. Next, this is a practical exercise. Basically, I will be taking up this if I'll get some time from 12:30 to 1:30, or maybe half an hour. I will just demo, but it's very easy, I think. If you'll study this, then you'll definitely our experts are there. They can explain you. But otherwise, I will take some time to explain about this live by in the ArcGIS or in the Survey of India map portal, how to create a user, how to download a map of your own area, then how to digitize some features, and how to prepare a map layout. That exercise, I think it's a maybe 1 hour exercise. I think 1 hour, 1.5 hour exercise you can do, so that you'll be familiar with the cartography or elements of cartography and different scales of map and different purpose of the your idea. So I think this session will be taken. Basically, Survey of India is the nodal agency which produces maps for our continent or for our country. The very old organization. It is 1767 it is established. Basically, Britishers established this, and in 2000 they have celebrated 200 years of bicentenary celebrations, and they have very state of art conventional state of art and conventional both. They have a system, and they're producing maps, but somehow people have not are not satisfied with their performance, because they have to be quite updated because of this huge development in India is happening, and every year the landscape is changing. There are a lot of things are coming up, so they are not able to upgrade their maps. The maps are still become old, and it's a very long process, basically mapping in as per their methodology. But now GIS and remote sensing has emerged, and a lot of private parties are coming up to help them to prepare latest maps. But however, we have to owe the Survey of India, and we have to see Survey of India as a government body. So we have to adopt whatever they are serving, for us. So Survey of India seat, basically, I would like to explain about all the cartographic elements. So that's all. Next. Yeah, thank you. If any questions, I can hear, can answer. Quick questions, I think. Already I have taken a lot of time.
If you have any question, you can ask. Just switch on your mic and you can ask.
Ravindra, if some questions I can explain.
Yes, sir, I'm asking them.
Yeah, please. Just give them mic so that I can hear and answer.
Sir, can you explain about fair mapping again? I didn't understand that.
So they are asking about fair mapping.
Yeah, fair mapping is basically while you are collecting information from field, you are not concerned about the color, pattern, line, feature. You will just sketch in a piece of paper in an unconventional way, or in unpleasant, or not good for visualization. When you see a map, you will see just a child is making a drawing, something like that. Of course, their locational accuracy is okay, and more about that. But for a general people, it is a simple line or maybe a very awkward symbol. So fair mapping is a process where you will focus on designing. Suppose, for example, road is there. You survey while surveying a road, you just put a single line. But generally that road is a highway, so you have to make it a double road. So a single line can be converted with devoting some amount of time into a double road in the lab. So that is a fair. That means the road is basically a double road. Highway, we should depict it in a double line road. So making a single line to double line is a fair mapping. But it is fair to us that when we see that, we can quickly grasp that that is a road. Similarly, all other features. While surveying, the surveyor doesn't care about the symbols, colors, or good visual perception. So definitely, there is a stage in between. You have to have a focus or time for developing a very beautiful mapping. I mean beautiful maps, so that people can generally identify the features easily. Is it? I think. Hope you got the fair mapping.
Uh, is satisfied, sir. One more question is there about map scale. Can you explain us them the map scale again, sir?
Map scale, basically, scale is a element, very vital element. I think why he or she has not understood. I would like to more about what is it exactly doubt map scale. Should I repeat the whole, or he has some specific doubt?
Sir,
Yes.
can you please explain again the map scale?
Yeah.
Because it's not getting on my nerves.
Yeah, basically map scale is a ratio of ground distance to paper distance. For example, you have a distance from one object to another object is 10 kilometer in ground. But that 10 kilometer cannot be directly placed in a piece of paper or on a screen, 14-inch by 14-inch screen. So basically, we have to have a scale that what is the ratio of ground to paper. For example, 1 is to 50. That means 1 kilometer in paper is 50 kilometer in ground. So that 10 kilometer of road which I am talking about can be represented in paper in how much of what is the length of, so that if 1 is to 50, if I'll say the scale, map scale, then it will be 50 times lesser scale. I am placing that 10 kilometer road. So you have to divide the meter into 50 parts. For example, 1 meter can be divided into 50 parts, then it will become, I think, 2 centimeter. So this 10 kilometer of road can be represented in map in 2 centimeter. So if you draw a line in 2 centimeter of line, then that will depict a 50-kilometer road. So that is map scale basically. Is it clear now?
Okay, sir.
I think
Okay.
Mr. Satyam and Dharmendra, you just explain them,
Yes, sir. Yes, sir.
because this is a very vital element. I think they should know. Just थोड़ा सा
Yes,
और
sir. We
उनको
will explain it, sir.
समझाए वहाँ स्केल कितना इम्पोर्टेंट है और बताओ.
Sir, there is no more question.
Okay. Uh, Someone can tell me about the idea, like what was the the training? किसी एक को
Uh,
दीजिए माइक,
can
थोड़ा बताएंगे मेरे को
okay, sir.
कि कैसा लगा ये. Hello. Overally, how it
Ye-
was?
yes, sir. Sir.
Please.
Sir, the overall session was good.
Hello.
Hello,
Speak.
sir.
Yes,
The oral session was good, and you have explained it very well
I
about.
can't hear you.
You speak.
Sir, the overall session was good, and you have explained it very well about the map making and cartography.
Okay.
Where you have explained in the beginning about the map, as well you have explained about the types of map, topographic maps. Where you have explained the types of map, you have explained about the topographic map, thematic map, geologic map, and cadastral map. In topography map, you have explained that topographic maps, it is a map to see the road, railway, boundaries, etc. And in thematic map, it shows the theme or the subject of the particular map. And in geologic map, it shows the geologic of this map. In cadastral map, it study about the detail of property boundaries. On
Yes,
the
thank you. Thank you. Whatever you have got, it's
yes,
okay. But at any time, any point of time, whatever you have a doubt, then you can ask because, of course, it's not a very like in a modern technologies. These are normally not visible to a student. But if you will practice these things, then for any kind of map making in modern technology, GIS, using GIS and remote sensing, these concepts, these fundamental principle will always work. So try to grasp this theory basically, and also get some practice. These are appears to be very normal, but it has some great significance of a accurate map making. So I request all that you should get devote some time in the home or in the your guest house, so that you can Google it. That all have been given is all from the Google's internet sources only. There is huge amount of knowledge, or I mean know-how is there in cartography. So you can study, you can have your own view of explanation and all. Any doubt you can keyword you can type it in Google, then you can get a good amount. But